Okay, continuing on our trip, of the 8 steps to X-ray a new language, we've sort of covered the first 3. And the next thing we can look at is how do you define classes? How do you describe collections of operations that are associated with an object? So we'll start out with a really simple example. This is sort of the hello world of defining classes. We will define a savings account, and we're going to assume that there's some existing class called account from which it inherits. We'll talk more about inheritance as we go. So what are some things that you have to do when you define a class in other languages? You have to have a constructor, something that will essentially manufacture a new instance of that class and return it. And you have to, among other things, decide what the attributes or the instance variables are associated with that class. So when I call savingsaccount.new, that will actually result in calling a function, unfortunately called initialize. A natural question at this point is, why is it that when I define a constructor, I need to call it initialize, but when I want to use it, I say new? Why aren't they the same? I wish I could tell you. This is one of those you just have to remember it. I'm really sorry. But at any rate, the sort of default constructor is always going to be called initialize, and I'm going to have it take a single variable or single argument that will default to 0 if it's not passed. So when I construct a new instance of a bank account, I can optionally pass a starting balance, but if I don't pass anything, it will default to being 0. And I will define an instance variable to track that. Remember, we said instance variable names start with an @ sign, and the instance variable is scoped to the entire class. So once I define this instance variable at balance, any other methods, instance methods that I define in the class will be able to see its value. Well, what if I want to get the value of the balance at any given time? I can very easily define a method called balance that just returns the value of that variable. And remember, I don't need to say the word return here. I could have said return at balance, but if I don't use return, the last expression evaluated in the method is the value of the method, and this is fewer things to type. The reason I have to do this, by the way, is that Ruby is very strict about data hiding. What I mean by that is that although I defined this instance variable at balance, and I said the instance variable is visible throughout the entire class and all methods that use it, however, it is strictly invisible from outside that class. So if I create a bank account object and I want to ask what its balance is, outside the bank account class, I cannot see the value of that balance. The only way that I can get it is to call a method that returns it. Because remember, everything is an object and everything interesting is done through method calls. This is actually really great because it means that the implementation of how the balance is calculated can be separated from the concept of an underlying balance. And when we talk about the Rails framework, we'll see a way that this ability is used to great effect to make the framework really nicely map your database tables. But for now, the important thing to remember is at balance is only visible within the class. So once I create a new bank account object, I need to have a method that explicitly returns the balance. Similarly, if I need to reset the balance to a new amount, from outside the class, I can't modify that instance variable. I need a method that will do it for me. But if I call that method balance equals, then I'll be able to do something like set a variable like a to a bank account. If I say a.balance, I will get back the value of the instance variable. If I say a.balance equals some new amount, it will call the balance equals method, which will set it to that new amount. Again, the first time you see this, it seems really weird. But what is it doing? It is separating the concept of getting and setting variables from the implementation of those variables. This is a deep and important thing, and it's one of the worth remembering things about Ruby. The idea that a bank account has a balance, that balance can be queried and that the balance can be set, that is public information. Anybody who wants to deal with instances of the bank account class needs to be able to do that. However, the way that the balance is maintained is none of anybody's business except the class. That's why the values of these instance variables are not visible outside the class. You have to explicitly expose them by creating getters and setters. And by the way, if I don't want an outside of the class code to be able to just set the balance to an arbitrary value, I just don't define balance equals. And now there's no way to do it because there's no way to modify the value of the instance variable directly. And I haven't provided a method that will do the setting for me. So the data hiding in Ruby in this sense is stronger than it is in many other languages. If I want to deposit, well, that's easy enough. I can define a method called deposit with one required argument, which is how much I'm depositing. And all I'm doing is adding that onto the existing balance. And if I want to define a class name, like what's the name of the bank? That's not a property of any particular instance of a bank account. That's a property of the account class. I can define a class variable, which is also only visible inside the class. So if a variable begins with an @ sign, or even with 2 @ signs, it cannot be seen at all outside of the class in which it's defined. Any access to that variable, or if you want to call it an attribute, whatever, any access to it from outside has to be via a method. Now, you would think this is a pretty common thing to do. So if it's the case that the only access to a variable is by defining a getter and a setter, you would think that there would be a more concise way to do that than having to essentially use this boilerplate code in every point in which you do it. And in fact, there is. This entire set of 2 methods can be replaced by that. Accessor is not part of the language. This is just a plain old method that is defined as part of the sort of Ruby core library. Basically what it means is, please create for me a getter method and a setter method that will set an underlying instance variable of the same name, right? And by the way, accessor could also take a string, but this is a canonical use of a symbol. It's one example of the use of a symbol. So _accessor basically tells the programmer who's reading this a bunch of things. First of all, it says there is an underlying attribute of this class, which is called balance. There is a setter and a getter that are being defined for you, which you now don't have to define yourself. And it's basically a shortcut that allows you, in the very simple common case, to avoid defining explicit getters and setters. So before we sort of do some coding examples, a quick review of where we are so far with Ruby's distinguishing features. It's strongly object-oriented, meaning almost everything, you're going to run into the idea that everything is based on classes and class encapsulation. There's no multiple inheritance. So when you do use inheritance, it's simple, single inheritance. Even simple things like integers are an object. Everything is done by calling a method on an object. And even doing things like getting or setting instance variables have to be done through accessor methods because those things are invisible outside the class. Symbols are a thing. Symbols are one of the Ruby idioms that you get used to using. They usually mean this is an enumeration or this is something that, even though it's sort of string-ish valued, it's not just something that could be an arbitrary string. Everything is done with a method call. And most of the time, the only thing you care about is if the receiver responds to the method. So remember in A.B, A is the receiver, B is the method. We don't care what A's class is. We just care if A can respond to the B method. And so things that look like operators, like plus and double equals, really are just syntactic sugar for plain old instance methods. And objects have types, variables don't, which is why we don't care about the type of A when we say A.B. We're going to talk about functionally flavored. So Ruby has collection idioms that we haven't seen yet, but collection idioms are basically how you do loops in Ruby and other things as well. And idiomatically, sometimes parentheses are optional.